There is a question that keeps resurfacing, not because we want it to, but because our explanations keep leading us back to it. What if the universe is not a thing that exists in space and time, but a process that generates space and time as it unfolds? What if reality is not something that simply is, but something that is continuously produced, constrained, and updated? For most of human history, we never asked this. We assumed the universe existed in the same way a landscape exists, solid, objective, and independent of observation. Time flowed forward. Space extended outward. Matter moved according to fixed laws. The role of science was to discover those laws, not to question their nature. That picture worked astonishingly well, until it didn't. The first cracks appeared when physics began probing extremes, the very large, the very small, and the very fast. Relativity dissolved the idea of absolute time. Quantum mechanics dismantled the assumption that objects possess definite properties before interaction. Suddenly, reality stopped behaving like a static structure and started behaving like something conditional. At first, this was treated as a technical inconvenience. Probabilities replaced certainties. Observers became part of equations. Measurement acquired a strangely participatory role. But gradually, a deeper realization emerged. The universe was not revealing hidden pieces of a pre-existing puzzle. It was behaving as if outcomes themselves were generated. This shift quietly changed everything. Because if reality is generated rather than revealed, then the most fundamental question is no longer, what exists? But, how does existence happen? Long before anyone spoke about simulations, physicists began to notice that the universe behaves less like a collection of objects and more like a network of relations. Properties arise only through interaction. Events are defined by context. Nothing exists in isolation. In this view, reality does not store states the way a library stores books. It updates states the way a process updates conditions. And once you think in those terms, the language of computation starts to appear, not as metaphor, but as structure. This does not mean the universe is running on silicon or code written somewhere else. It means that the universe behaves as if information is being processed under constraints. That idea gained explicit philosophical form in the early 2000s when a simple but unsettling argument was put forward. If intelligent civilizations tend to survive long enough to develop advanced computational capacities, and if they have any reason to simulate their past, for research, curiosity, or preservation, then simulated observers would eventually outnumber biological ones. Under those assumptions, the probability of being in a simulation becomes difficult to ignore. The power of that argument was not in its conclusion, but in its logic. It forced us to confront the implications of our own trajectory. It asked, if we continue doing what we are already doing, computing, modeling, simulating, what kind of universe do we implicitly assume we inhabit? But the simulation hypothesis did not emerge in a vacuum. It arrived at a moment when physics itself was struggling with the nature of reality. At the smallest scales we can meaningfully describe, space and time appear quantized. Below a certain threshold, distance and duration cease to have physical meaning. This is not a limitation of measurement. It is a limitation of definition. Reality itself does not seem to exist at infinite resolution. This is deeply counterintuitive. We expect nature to be continuous, like a smooth fabric. But instead, it behaves more like a system with a minimum unit, a resolution limit. That alone does not prove anything, but it aligns uncomfortably well with how rendered systems behave. At the same time, quantum entanglement shows us something even stranger. Correlations appear that do not respect spatial separation. Two particles can behave as a single system regardless of distance, as if space were not the medium that connects them. The implications are subtle but profound. If information can be correlated without traveling through space, then space itself may not be fundamental. It may be an emergent structure, a way of organizing relationships rather than the arena in which they occur. Once that possibility is taken seriously, a new picture begins to form. Not a universe made of things moving through space over time, but a universe made of events, relations, and updates. Information becomes central. This is where the conversation often becomes confused, because information sounds abstract. But in physics, information is not optional. It is conserved. It has limits. It shapes entropy. Black hole physics, in particular, forced physicists to confront the idea that geometry, energy, and information are inseparable. The universe, at its deepest level, does not appear to be made of matter alone. It appears to be made of information structured by constraints. That still does not imply a simulation in the popular sense. But it does imply computation. Not digital computation, but physical computation. A system in which states evolve according to rules, probabilities, and interactions. At this point, an uncomfortable question emerges. If the universe computes, what exactly is being computed? This is where consciousness enters the picture, not as an answer, but as a complication. Consciousness refuses to fit neatly into physical models. We can correlate neural activity with experience, but correlation is not explanation. We can map brain processes, but mapping is not meaning. The subjective fact of experience remains stubbornly irreducible. Some theories treat consciousness as an emergent property of sufficiently complex computation. Others argue that consciousness may be fundamental, not something produced by computation, but something that computation organizes. If consciousness is fundamental, then a computational universe is not cold or mechanical. It is experiential. It is not a simulation being run for someone else. It is a process that includes experience as part of its structure. This reframes the entire discussion. The question is no longer, are we characters in a game? That framing trivializes the problem. The deeper question is whether reality is participatory, whether observation and experience are not passive outcomes, but active elements in how the universe unfolds. Quantum mechanics already hints at this. Measurement does not merely reveal properties. It participates in outcomes. Observation changes systems. The act of knowing cannot be fully separated from the thing known. Once again, this does not prove anything, but it forces us to abandon the idea of a detached observer standing outside reality. Whatever the universe is doing, we are inside the process. And if we are inside the process, then the next question becomes unavoidable. Is the process static, or does it evolve? If the universe computes, it is tempting to imagine it executing a fixed program, a set of eternal laws written once and followed forever. But that picture no longer fits what we observe. The laws of physics look stable, but stability does not necessarily imply permanence. In complex systems, stable patterns often emerge from iteration, not design. Rivers carve predictable paths, not because the rules are written in stone, but because feedback stabilizes flow. Some cosmological theories suggest that even physical constants may not be fixed in the deepest sense. They may vary across epochs or universes, with stability emerging through selection-like processes. In this view, the universe does not execute a frozen script. It experiments, iterates, and stabilizes patterns that persist. That begins to resemble not a static simulation, but a living system. Living systems are not defined by intention. They are defined by feedback. They maintain structure by responding to change. They are neither random nor rigid. They occupy a narrow corridor between chaos and order. Our universe appears to do the same. This perspective also changes how we think about cosmic silence. For decades, scientists have asked why we do not see evidence of other intelligent civilizations. The absence feels eerie. But absence only becomes paradoxical if expectations are misplaced. Complex systems often hide most of their structure. Life on Earth was invisible to the cosmos for billions of years. Technological civilizations may be rare, brief, quiet, or fundamentally mismatched with our detection methods. Speculation about optimization or constraint does not require a designer. It only requires acknowledging that complex systems economize. They do not display everything they contain. If reality is computational, observability itself may be constrained by structure, not intention. At this point, many people instinctively ask about free will. If the universe computes, are our choices predetermined? That question assumes free will must mean escape from constraint. But no meaningful system operates without constraints. Music requires scales. Language requires grammar. Life requires chemistry. In a process-based universe, free will becomes local agency, the ability of subsystems to influence outcomes within bounds. Not absolute freedom, but meaningful participation. Your choices matter not because they override the system, but because they are how the system unfolds at your scale. This leads to the most unsettling implication of all. If the universe is computational, and if conscious beings arise within it who begin to understand its structure, then understanding itself becomes part of the computation. Knowledge is no longer external. It feeds back into the system. A universe capable of being understood by its own subsystems is no longer just running. It is reflecting. This creates a strange loop. The more we understand reality, the more we change how reality behaves, not necessarily at the level of particles, but at the level of meaning, action, and choice. At that point, asking whether we live in a simulation begins to feel like the wrong question. The better question is, what kind of universe gives rise to beings who can ask this at all? A dead universe would not care. A static universe would not reflect. A meaningless process would not generate wonder. Whatever this universe is, it produces structure, experience, and inquiry. It generates observers who question their own existence. It allows knowledge to matter. Whether we call that a simulation, a computation, or something else entirely, may be less important than recognizing what it implies. Reality is not indifferent. It is not finished. And it is not separate from those who experience it. The simulation hypothesis, at its best, is not a claim about deception. It is a challenge to our assumptions about what it means for something to be real. Perhaps reality does not need to be solid to be meaningful. Perhaps permanence was never the point. Perhaps participation is. Whatever the ultimate nature of the universe turns out to be, one thing is already clear. We are not standing outside it, looking in. We are inside it, questioning, exploring, and shaping its unfolding. And that, more than any speculation, may be the most important fact of all.